An ideal op-amp circuit equation is a mathematical expression that relates the input and output voltages of an ideal op-amp circuit. An ideal op-amp is a device that has infinite gain, infinite input impedance, zero output impedance, and zero input offset voltage. There are different types of ideal op-amp circuits, such as inverting, non-inverting, summing, differential, integrator, and differentiator. Each of these circuits has a specific equation that describes its behavior. Here are some examples of ideal op-amp circuit equations. Inverting amplifier. This circuit has a negative feedback and produces an output voltage that is proportional and opposite to the input voltage. The equation for this circuit is where $V out, is the output voltage, $V in, is the input voltage, $R_F is the feedback resistor, and $R_ in, is the input resistor. Non-inverting amplifier. This circuit has a positive feedback and produces an output voltage that is proportional and in phase with the input voltage. The equation for this circuit is summing amplifier. This circuit has multiple inputs and produces an output voltage that is proportional and opposite to the sum of the input voltages. The equation for this circuit is differential amplifier. This circuit has two inputs and produces an output voltage that is proportional to the difference of the input voltages. The equation for this circuit is integrator amplifier. This circuit has a capacitor in the feedback loop and produces an output voltage that is proportional to the integral of the input voltage. The equation for this circuit is differentiator amplifier. This circuit has a capacitor in series with the input and produces an output voltage that is proportional to the derivative of the input voltage. The equation for this circuit is. These are some of the common ideal op-amp circuit equations that you can use to analyze or design op-amp circuits. For more information on op-amp circuits and formulas, you can check out these web pages. I hope this helps you understand ideal op-amp circuit equations better.